What if scientists could point to the exact place where the next mega earthquake might begin? Well, now they think they can, and the location is dangerously close to one of the world's biggest cities. What they found under the sea is shocking, and it could change earthquake warning forever. Scientists have made a discovery that sounds like something from a disaster movie, except this is real. Deep beneath the Marmara Sea, near Istanbul, Turkey, researchers have found signs that may reveal where the next major earthquake is most likely to start. And this is not just a random guess. It comes from detailed mapping, long-term earthquake simulations, and new ways of studying what's happening under the seafloor. For years, scientists mostly focused on cracks and faults they could see on land. That made sense. Because land is easier to study. But the real danger in this region may be hiding underwater. And what they found beneath the Marmara Sea is deeply concerning. This area sits near one of the most active tectonic zones on Earth. Huge sections of the planet's crust are constantly pushing, scraping, and pulling against each other. That movement builds stress underground over long periods of time. Think of it like bending a plastic ruler again and again. At first it holds, but eventually it snaps. That snapping is what causes earthquakes. The Mediterranean region is especially risky because it lies at a crossroads of moving tectonic plates. Over time, parts of the crust there become thinner and weaker, and when the crust is weak, it cannot hold pressure forever. Now, scientists say they have identified a likely starting point for a future large earthquake, a spot beneath the Marmara Sea where different types of crust meet. In simple terms, it's where stronger and weaker parts of the Earth are rubbing against each other. That kind of boundary can become a dangerous breaking point. And if a big rupture begins there, the effects could spread far beyond the sea. One major concern is Istanbul, a giant city with over 15 million people. It sits frighteningly close to this fault system. A strong earthquake there would not just shake buildings. It could damage roads, bridges, power systems, and water lines. Older neighborhoods would be especially vulnerable. For a long time, many scientists feared the main fault under the Marmara Sea could break all at once in one giant rupture, like a zipper opening from one end to the other. If that happened, it could create a devastating megaquake. But new research suggests something slightly different. Instead of one huge uninterrupted tear, the fault seems to behave more like connected pieces that break in sections. That may sound a little less terrifying, but don't relax too much. A series of large earthquakes can still be extremely destructive, especially when they strike close together. So how did scientists figure this out? They used detailed 3D computer simulations that recreated more than 10,000 years of earthquake history. These models included real measurements from the region, such as underground heat, rock strength, fault friction, and the thickness of sediments under the sea. And this is where it gets really interesting. Scientists discovered that the heat deep below the seafloor changes how the fault behaves. Warmer rock bends and flows more easily than colder rock. That means some areas underground act almost like a natural break, slowing how far a rupture can spread. In the central Marmara region, thick layers of mud, sand, and buried debris sit above warmer crust. Those layers affect how pressure builds and how energy is released. When researchers added these details to their models, the results finally matched known earthquakes from history. That includes the powerful earthquakes of 1766 and 1912. And according to these new simulations, the fault in this area may still produce very dangerous earthquakes, but likely not the single giant monster rupture once feared. Instead, it may create quakes around magnitude 7 to 7.3, depending on which section breaks. Now let's be clear, a magnitude 7 earthquake is still a major disaster. That kind of shaking can collapse weak buildings, crack highways, trigger landslides, and seriously damage a city. It may not be the absolute worst-case scenario, but it is still more than enough to cause tragedy. Scientists also found that not every part of the fault behaves the same way. Some western sections appear to produce stronger earthquakes more regularly, around every 150 years or so. Eastern sections may create smaller but still dangerous double earthquakes, where two strong quakes happen close together. And then there's another strange behavior, creep. That's when part of a fault slowly slides without causing a major earthquake. Instead of snapping suddenly, it quietly releases pressure over time. Scientists have found signs of this in the Central Basin, using GPS data and patterns from small repeating earthquakes. That sounds like good news, and partly it is, but creep does not remove all the danger. It only affects certain sections. Other parts of the fault may still be storing huge amounts of energy, and that's the scary part. One section of this system hasn't produced a major rupture since 1894. That means strain has been building there for more than 130 years. In earthquake terms, that is a very long time. And the Marmara Sea is not the only warning sign in the region. Farther south, near the Greek island of Santorini, scientists recorded more than 28,000 earthquakes in just a few months in early 2025. Most were small, but some were strong enough to crack walls and force emergency action. At first, this looked like normal tectonic activity, but then scientists noticed something unusual. The earthquakes were moving. Their center gradually shifted toward Colombo, an underwater volcano just offshore. That movement suggested something else was happening below the surface. Magma was rising. Researchers estimate that a massive amount of molten rock surged upward from deep underground, then stopped a few miles below the seafloor. It never erupted, but it still changed the stress underground. And that matters a lot, because when magma moves, it can fracture rock, reshape underground pressure zones, and increase the chance of future earthquakes. In other words, even when a volcano doesn't erupt, it can still make the ground more unstable. This is why scientists are watching the Mediterranean more closely than ever before. The good news is that they now have far better tools than in the past. Today, researchers can combine real-time earthquake data, underwater pressure sensors, gas measurements, and advanced computer models to track what's happening beneath the surface. This helps them spot dangerous patterns earlier than ever before. But one of the most exciting new ideas might be hiding in something you'd never expect. Undersea internet cables. Yes, the same fiber optic cables that carry internet across oceans may also help detect earthquakes and tsunamis. Here's how it works. When the ground shakes or the seafloor shifts, tiny changes travel through those cables as changes in light signals. Scientists can measure those changes and use them to detect movement underwater. That's a big deal because putting thousands of earthquake sensors across the seafloor is expensive and difficult. But internet cables are already there, stretching across huge parts of the ocean floor. If scientists can fully use them as warning tools, they may be able to detect underwater quakes faster and more accurately than ever before. And in an emergency, even a few seconds can save lives. Those few seconds can stop trains, shut down gas lines, pause elevators, and give people time to move away from windows or dangerous structures. That may not sound like much, but in a major earthquake, seconds can mean everything. So can scientists stop the next mega earthquake? No. And they cannot stop tectonic plates from moving. They cannot cool magma underground. And they cannot prevent stress from building beneath the Earth's crust. But what they can do is understand the danger better than ever before. And that matters, because the more accurately scientists can identify where earthquakes are likely to begin, the more cities can prepare, strengthen buildings, improve warning systems, and save lives before disaster strikes. And right now, all signs point to one chilling truth. The next major earthquake in this region may not be a mystery anymore. It may already have a target. The Earth is always moving, even when everything feels still. And now scientists may be closer than ever to knowing where the next massive quake could begin. If you enjoyed this video, make sure to like and subscribe so you don't miss our next deep dive into the mysteries and changes shaping our world. See you in the next one.